in order to graph a parabola, you basically need to have 3 points. You need the vertex and you need 2 other points. So no matter what form we get the equation in, we need to figure out how to get at least 3 points to graph. Vertex form looks like this. Y equals A times x minus h squared plus k. If that looks familiar to you, that's because that's the exact format that we looked at the last time that we had notes. Remember, the minus h moves the graph side to side horizontally, and it's backwards, and the k moves the graph up and down. The vertex is hk, and I want you to write, notice h is opposite. So in vertex form, it says minus h, but then positive h is your x value of your vertex. That's because minus h would move the graph to the right, plus h would move the graph to the left. So you're moving that vertex from 0, 0 to a different location. And then the k is normal. If it says plus k, it's positive k. If it says minus something, it'd be negative something. We're going to skip talking about these for a second. The axis of symmetry. Every parabola has a symmetry line that goes straight through the middle of the parabola, and that goes directly through the vertex. So the axis of symmetry is a vertical line, x equals, and it's the same as the first part of your vertex. So I want you to notice that this is that first part of your vertex, and it comes from that part of the formula. The plus k gives you that second part of your vertex. So with vertex form, we very easily can find our vertex. And I'm going to skip graphing A because we graphed that on Friday. We know what that looks like. It's just a standard parabola with a vertex at 0, 0. Let's go to B. And I'm going to number and color code my steps so that everything you can hopefully follow. Step 1, we are going to find the vertex from this formula. F of x, or y equals, x plus 6 in parentheses squared minus 2. So the plus 6 is going to tell us the first part of our vertex. What is the x coordinate for our vertex going to be? Negative 6. If it says plus 6 in the formula, that means that the graph is going to move left 6. It's always backwards. So if we move from 0, 0, left 6, that x coordinate is going to be negative 6. The minus 2 is going to move the graph up or down, and that will give us the second part of our vertex. So that is going to be minus 2. Notice the first part of your vertex is opposite. The second part of your vertex is the same. Let's plot this vertex. Negative 6, negative 2. From our exploration on Friday, we looked at how plus 6 moves the graph left 6. The minus 2 moves the graph down 2. So our vertex used to be right here at 0, 0. That vertex moved left 6 units, down 2 units, and that is its now current location. Step 2 is to get the axis of symmetry. We will use AOS for axis of symmetry. And here's the really easy part. It's exactly the same as the x value of your vertex. There is a symmetry line that goes directly through this vertex. At the very beginning, I said that we needed 3 points to graph. How many points do we currently have? We have 1 point. But we have a symmetry line. So if we can find 1 point on the right side or the left side of the graph, we can reflect that point over. So we really only need to find 1 more point. And here's how we're going to try to find this point. we are going to pick an x value close to the axis of symmetry. Our axis of symmetry is at -6, so we want to pick something like -5 or -4. We want something that's 1 or 2 units away from the symmetry line. I usually go 2 units away from the symmetry line just because it makes it easier to graph the parabola. So if my symmetry line is at -6, I'm going to pick the x value -4. I want to know if my x is -4, what's the y value? What point is that on my graph? To find that, we're going to plug that -4 into the equation. And here's where your calculator comes into play. Type it in exactly as you see it. Just stick the -4 in place of the x. -4 plus 6, close your parentheses, squared, -2. Make sure that everything looks exactly the same except that you've plugged -4 or whatever x value you chose into x. When I hit enter, it tells me that my y value is 2. So this is still step 3. I plugged in -4 and I got the y value 2. That means the point -4, 2 is on the graph. Step 4 is to reflect that point over the symmetry line. How many units away from that green symmetry line is that pink point? 2 units. Go 2 units on the other side of the symmetry line. That's enough information that you can now draw in a U-shaped graph, and our parabola has been graphed. We also need to talk about domain and range. This is the super easy part. Domain. Domain is referring to the x values. We can put any x value into this graph, into this equation. So our domain is all real numbers. Have you seen this symbol before? Looks like a capital R with a double stem. That symbol means real numbers. But instead of having to write out all real numbers every time, you can write the word all and then a capital R with a double stem, and that stands for real numbers. Okay. I do want to take a moment to go back over here. I'm just going to show you really quick what this graph looks like. This is a normal parabola. It also has the domain all real numbers. Helpful hint, parabolas, the domain is all real numbers every single time. So if there's one point that you want to definitely get on every test, if it's a parabola, what's the domain? All real numbers. The range. This vertex is also called a minimum value. The y value of this point is 0. All of these other points are above that. So a normal parabola that hasn't been messed with, the range is y is greater than or equal to 0. If we move that parabola, say, down 2 units, that's going to affect this range. The range of our new parabola is y is greater than or equal to -2. This vertex is a minimum value. That minimum value is -6. The minimum is the y value. Sorry, not -6, -2. All of those other points, this pink point, the y value is bigger than -2. The orange point, the y value is bigger than -2. Every single point on this parabola, the y value is going to be larger than -2. We're going to skip example C and do this for example D. Your first step is going to be to find your vertex. So step 1, our vertex is it +3 or -3? +3, +4. Remember, the +3 comes from the opposite of whatever's in the parentheses. The 4 comes from whatever comes after the parentheses. So let's plot the point 3, 4. From this information, we also know that our symmetry line is at x equals 3. That's directly, vertically through that vertex. You don't have to have a dashed line drawn, but it's helpful to be able to see that symmetry line. We currently have all of the information that we can really get from this equation. We need another point. So for step 3, we need to pick an x value that is 1 or 2 units away from our symmetry line. Our symmetry line is at 3, so we want to choose 4 or 5. I usually go 2 units away, so I'm going to choose 5, but if you wanted to choose 4, you also could. You could also choose 2 or 1, anything that is 1 or 2 units away from that symmetry line. That number gets plugged into your equation, and you can type this into your calculator so you don't have to do the math in your head. And I find out that this extra point on my parabola is at the coordinates 5, -4. Does this location surprise you?
No.
Why not? Okay, so some of you noticed that there's a negative in front of this, so the parabola needs to open downward, so this location shouldn't really surprise you. Your fourth step then is to reflect that point, 5, -4, over your axis of symmetry. It's 2 units away from the symmetry line. Go 2 units on the other side. There's the third point on your parabola. Now you can draw it in. By getting to know these formulas and what all the numbers in the equations mean, you can check yourself. Like you all said, hey, the graph should open down because of this negative. If you had graphed that point in step 3 and it looked like your graph was going to open upward, you'd be like, okay, hold on. I must have done something wrong. Let me go back and check my work. Maybe I put my vertex in the wrong spot. Maybe I calculated the point wrong. So check yourself. If the graph is supposed to open downward, make sure it does. Okay, the easiest part. What is the domain? All real numbers. The range comes from the minimum, or in this case, we call it a maximum. This one's a maximum because when the graph is flipped over, it's at the top of the graph. There's nothing above that. This maximum value is 4. That's the y value of your vertex. So because this graph moved up 4, it's going to shift the range to 4. So that is very connected with the up and down movement. Now, is the rest of the graph above that number or below that number? Below that number, so we are going to put less than or equal to. Because the graph is flipped, the rest of the graph is below the maximum. The range is y is less than or equal to. Up here in example B, the graph was above the minimum, so it was greater than or equal to. If the graph is above, greater. If the graph is below, less.